Previously, we looked at discrete random variables. Now we're going to talk about continuous random variables. A continuous random variable is a random variable, capital X, where the data can take on infinitely many values. So some examples of a continuous random variable would be like how long something takes, so time, or maybe a distance, like how many miles you've driven. Those are both examples of a continuous random variable. When we graphed a probability distribution of a discrete random variable, we graphed a histogram. But in a continuous random variable, we're going to graph what's called the probability density curve. The probability density curve or function can actually take on two different forms depending if you have a uniform distribution or a normal distribution. A uniform distribution of a continuous random variable, we have here the continuous variable between A and B, and then the height of the curve inside the probability. This is the probability. It's going to equal 1. And notice that it's uniform. So at any particular moment, you have the exact same height of our curve. Okay. The next type of probability density curve will be a normal distribution. The normal distribution here, you'll have the curve, and your distribution will be here where this is 0, and the area under the probability distribution is equal to 1. So this entire curve represents 1. We're going to take a look at each one of these individually now so we can better understand them. A uniform distribution is the probability distribution where each continuous random variable has the same probability. And there are some important things about the uniform distribution here. First of all, your x, meaning your random variable, is between A and B. The second thing is that the area under any probability distribution must be equal to 1. And the third thing is that the height of the rectangle will always be area divided by the length. Which means in that case, here we have a probability distribution. Let's say it's going between A and B, and its area is 1. So if area equals length times width, the area under the entire thing is 1. So we have 1 is going to be equal to the height times that would be B minus A. So to find the height of this rectangle, the height will equal 1 over B minus A. Now the reason that height is important is because it's this line. Any point on this line has that height. Okay? So with that, we can do some examples to help us better understand what the whole distribution actually means. Alright, so the average amount of weight gained by a person over the winter months is uniformly distributed from 0 to 20 pounds. Draw a probability density curve for this situation. So let's take a look here. We've got the red. We've got a graph. Our random variable is anywhere from 0 to 20 pounds. So let's start at 0 to 20 pounds. Now we know that this is uniformly distributed because the problem tells us so. We want to figure out the height of this. Well, the total area under the curve is 1. It has to be 1 because that's the definition of a probability density curve. So, to find the height of this curve, if area equals 1, or length times width, our width is 20, so we have 1 divided by 20 would give us the height of the curve. All right, so let's see what that means in terms of interpreting what probability is. Now, on probability density curves, you can't find the exact probability at one particular moment because it is continuous. So because of that, we like to find the probability of something being less than or greater than. So, for example, what is the probability that a person will gain more than 10 pounds? Or what is the probability that someone will gain less than 5 pounds? All of those are examples of something you could do with this uniform distribution. What is the probability then that a person will gain between 5 and 10 pounds? So what we need to look at here is the probability density curve. It's going between 0 and 20, but we just want to find the probability that a person will gain between 5 and 10 pounds here. All right, well, we know the height of my density curve is 20. And what is the length between 5 and 10? Between 5 and 10, that's 5 units. Okay, so to find the probability that somebody will gain between 5 and 10 pounds is equal to my 5 units times my probability, which is 120, or my height, not my probability, my height, which would be 5 times 1/20th, which is 5/20, 1/4, so 0.25. So the probability that somebody would gain between 5 and 10 pounds is 25%. Now, most of the time, our probability is not uniformly distributed. More than often, things are more likely to happen when they're centered closer to the mean. So we're going to take a look now at the other type of probability distribution of continuous random variables. In the normal probability distribution of continuous variables, we are going to find the probability under a normal curve of specific probabilities. However, when we have different probabilities, let's say that we have a value, we're going to call that a z value. You'll see why later. Let's say we want to find the value of something being less than z, or even something greater than z, or something being in between two values. We can find the probability using a specific method. But before we do that, let's talk about the normal curve one more time. Under the standard normal curve, the area is equal to 1. So that's the first thing we need to know. So we have this curve here. The total area underneath the curve as you go out towards infinity is equal to 1. The other thing about the standard normal curve is the center is at 0, 0. Remember when we did the 68, 95, 99.7 rule, or the empirical rule? We had a mean, and then we calculated 1 standard deviation out, 2 standard deviation out, 3, and so forth. That is the same graph here, but our mean is at 0. Okay, and our standard deviation here will be 1. All right, the second thing, since the center is at 0, the mean is 0. All the positive values will be to the right of the mean, and all the negative values will be to the left of the mean. These will give you negative values, and these will give you the positive values. And the last thing to know about a standard normal curve is that the area under the curve does in fact represent the probability. So if we can find the area under the curve, we can calculate what the probability is. Now we're going to take a look at a special chart that's going to help us calculate these probabilities. We're going to learn how to calculate using the chart the probabilities to the left of certain z-scores. All right, so if we can calculate the probability of certain z-scores, or the probability of them to the left, we can get the probability to the right if you know the total area is 1. It would just be 1 minus that. So we're going to take a look at the chart. This chart, if you have the book, it's in the back flap of the book. You'll see it will say Z table. But you can also look up the Z chart. Anywhere online and it should come up. So the rest of this video is just going to be how to interpret the chart and relate it to what's called a z-score. Remember, we've already learned how to find a z-score. We're going to be given z-scores here though, and we're going to use them on the chart. So let's talk about how to find the probability using the z-table. Here we're only going to find the probability to the left. After I talk about this, I'll tell you how to find the probability to the right, or even the probability of in between two z-scores. So first, given a specific z-score with a ones place and then a tenths and a hundreds place. So it should be a number, dot, number. Okay, that's how your z-score has to be. Otherwise, you can't use the chart. So after you find the ones, the tenths, and the hundreds place, you're going to look for the ones and tenths place on the left column of your z-table. And then, after you do that, you're going to find the hundreds place on the top row. Then you're kind of going to go down in between the two and find where those two intersect. That number will be the probability to the left of the z-score. And remember, to the left of the z-score means less than that z-score. So here is an image of the z-table for the negative z-scores. These would be the negative z-scores and the positive z-scores here. So notice that the picture at the top, this right here and this right here, shows that you're finding the area to the left of the z-score. So if you want to find, let's say, the probability of z being less than 1.32. And we want to use the chart here for that. What you're going to do is, it is a positive z-score, so we'll use the positive side here. So you have 1.3, you'll use that on this column, and then the hundreds place is 2, so that would be the 2. So we're going to go 1.3 and then 2 right here. So 1.32. Then our final answer will be this value that I highlighted. So 0.9066. So that means the probability of our z-score being less than 1.32 is 0.9066. And that would be our answer for the probability. Now notice once again that the probabilities only give the area less than. But if you can remember that the area under a curve is 1, then to find the area to the right shouldn't be too difficult. To find the area to the right, you just go 1 minus the probability of the area to the left. So it's the complement of the area to the left. All right, let's look at some examples here of using the z-table. All right, so we have the probability that z is less than 1.52. So we go to 1.5 and then find the 2 here. And the probability of that would be 0.9352. So the probability of z being less than 1.92 would be 0.9352. Now to find the probability that z is greater than 1.52, we would just go 1 minus that, because they are opposites of each other, which is 0.0648. So then what we're going to do is, if we want to find the probability that z is less than negative 2.71, we're going to need to use the negative side of the chart. So let me put that up. So now to find the probability of our z-score being less than negative 2.71, we're going to go find negative 2.7, which is here, and then the 1, which is here, and we're going to find where those two meet, which would be right there. So the probability of z being less than negative 2.71 would be 0.0034. So to find the probability that z is greater than that, we will go 1 minus 0.0034, which will be 0.9966. So our final answer of that would be 0.9966. If you look at these two together on a chart, it would be the left side of negative 2.71 and the right side of negative 2.71, which would add together to equal 1. So the last one is looking at a probability in between negative 0.35 and 1.75. So let's take a look at that. We'll need both sides of the chart on that. So finding the probabilities between these two will be the area in between both of them. So what you do is you find the probability of z being less than 1.75, so that would be all of this less than it, and subtract this probability of z being less than negative 0.35, and that will give you the area in between the two. So let's take a look at that. Alright, let's first find the probability of 1.75, or sorry, z being less than 1.75. That probability, if we look at the chart, will be 1.7, and then the 5 is this column, so we're going to find where those intersect, which would be right there, 0.9599. Then we need to find the probability of z being less than negative 0.35. So we're going to go negative 0.3 and then the 5 column, which will be right there. So that would be 0.3632. So if we do subtract them, we get 0.5967. So our final probability between those two values is 0.5967. Now, we are not limited to just finding the probabilities with a given z-score. If we do have the probability, we can also actually find the closest z-score there. So if I wanted to find the z-score for a given probability, so find the z-score with a given probability of 0.60, we're just going to look for the probability that is closest to that z-score. So, or closest to that probability. So we're going to look for 0.60. So if we look here, right there is going to be the value that has the probability closest to our z-score. So that means the z here would equal 0.25. So that is the z-score that goes with that probability.